Okay, welcome our SVM 12th standard students. Today we are going to see optical fiber in optics lesson. In our optics lesson, we have a optical fiber. That optical fiber used for what purpose means? It is used to transmit a light signal from one place to another place for long distance. One place to another place we can transmit a light signals. I think our informations are going to converted as a light signals. That light signals are going to transmit through the optical fibers. That optical fibers works on the principle of total internal reflection. Optical fiber works on the principle of total internal reflection. For total internal reflection making, we need two conditions. Necessary condition we need two. What is that means? Light must be passes from denser medium to rarer medium. Light must be passes from denser medium to rarer medium. Then our angle of incidence in our denser medium is greater than the critical angle. It makes a total internal reflection. Then these optical fibers made up of what material we want to see. That optical fiber is made up of a glass or plastic. Glass or plastic. They are in a cylindrical shape. Size is very thin. It is in the order of less than millimeter size. It is in the order of less than millimeter size. So we will take list our points. One is optical fibers used to transmit light signals. That light signal is nothing but information signals. Information signals. Okay, optical fibers used to transmit light signals from one end to another end. That light signal contains the informations. Light signal contains the informations. Then second point is, for what principle there we are using means, we are using a total internal reflection. So used in optical fibers, that is a principle used in optical fibers, is total internal reflection. Okay, it is used what purpose we will see, and what principle we are using, there we go through that. Next, that is in a cylindrical shape, which may be made up of either glass or plastic. Optical fibers made up of glass or plastic. Glass or plastic. There we have a two medium in each cylindrical shape fiber. There we have here two mediums in a cylindrical shape fiber. The diagram now we are going to take a small piece of fiber we are going to draw. It is in a what shape? That is cylindrical shape. We are mentioning like that. Not only that single medium, there we have a two medium, inner medium and outer medium. Like that, we have a optical fiber cable. One of that cable which is in that size is very small, shape is in a cylindrical shape. Then we have a two medium in the optical fiber. It is a core, inner medium, called as a core, outer medium in our cable, outer medium. That may be called as a cladding. Outer medium is called as a cladding. In a optical fiber, we have here two mediums, inner and outer. That is core and cladding. The two are not having a same refractive index. The refractive index of the core is greater than that is refractive index of the core is greater than that refractive index of a cladding. Then only when light tries to move from core to the cladding, if its angle of incidence either equal to critical angle or greater than the critical angle, that light makes a total internal reflections. So that's why light can be transmitted from one end to another end. That is, it moves from the interface of core to the cladding, but their angle of incidence I greater than that critical angle, then automatically light passes from one end of that cable can be makes total internal reflection through that core of our fiber cable, and finally it reaches that opposite end. So there we are transmitting a information signals in a communication system as a light signals. Information signals are transmitted as a light signals through the fiber cables. Mostly we are using the fiber cables in a communication systems. Example, in a telephone lines, olden days electrical cables are used. There we have some or lot of drawbacks is there. That drawbacks are overcome by the optical cable. One of that drawback is when electrical signals, that is telephone signals transmitted as electrical signals through the electrical cables, between the transmitter to the receiver, any electrical disturbance we have, noise is interacted to the signals. At the time of receiving the signal, their informations with noise can be received. We cannot easily eliminate that noise. But here, if we use this optical cable in our telephone system, between the transmitter to the receiver, electrical noise cannot interact. Because electrical signals cannot interact with that optical signals, because here that signals are passed as optical signals. Anyhow, there we are using the principle total internal reflection. Two mediums we have, core and cladding. Refractive index of that core is greater than, then refractive refractive index of gladding, refractive index of gladding. Then only when light moves from a core to the gladding, it obeys the condition for making a total null reflection. If the angle of incidence is greater than the critical angle, so light can be transmitted through the core itself. Whatever may be you make, if you bend that fiber cable or twisting the fiber cables, the signal will not comes out from the core of that optical fiber. So this also one of the major advantage. Even you are twisting that fiber cable or bending that fiber cables, the signals will not passes from a core to the gladding and as well as comes out that fiber. So it will always transmit through the core itself, because most major advantage is works on the principle of total internal reflection. Okay. So core is the inner part, gladding is the outer part. Core is the inner part, gladding is the outer part. Which one is the inner part? Core is the inner part and gladding is the outer part of that cable. So there we have some conditions. We want to make to enter the signals from outside the cable to the inner of the cable. At the time we want to see very clear that entering angle inside that cable is most important. Certain range of angle we want to use. Above the angle, if you incident, then signal will not make a total internal reflection. Core to the gladding, angle of incidence are less than that critical angle. If core to the gladding, angle of incidence, interface angle of incidence is less than the critical angle, that light will be comes out. But what purpose here we are using? Transmitting a signal from one end to another end, enter beginning and comes out. Between that, the signal will not comes out. So that is the most major important is one of that angle name is acceptance angle. If that angle of interface from outside to that core, certain angle of incidence it want to make. 0 to certain angle only, if it is entered, that light is makes a total internal reflection and passes through the core itself and reaches that other end. Above that angle, it makes a refraction, comes out through that gladding. So we will see the diagram with acceptance angle. So for that purpose, we are going to take a diagram, outer medium, core medium and gladding. So diagram we are going to take. Actually it is a cylindrical shape only. For our angle mentioning purpose, we are going to take like this. Inner part. It is called as a core. Outer part, gladding. Then we have the axis of that fiber. We have a axis of the fiber. It is outer surfaces, outer face. From this only we are going to pass the signal, light signal to inner. So that's why here we are going to take on three mediums: outer side medium, core medium and gladding. Each one having certain refractive index. So the core refractive index we are mentioning, that is N1. Gladding refractive index we are going to take on N2. Outer medium, generally it is air medium, their refractive index is N3. Our signal source, where we have means outside the cable only we have a signal source. Signal source generate a light signals. One of the light ray we are going to take on. That ray is going to enters in our optical fiber. At one end is the beginning end, that can be taken as a receiving end. Is a transmitting end, that can be taken as a receiving end. From the transmitting end of our fiber cable, the light ray can be entered. It will make a certain angle with the axis of that core. So that's why let me assume this is the incident ray. It is a incident ray from outside the cable to that inner. So, but what may be happen means going to make a refraction. It makes a refraction from rarer medium to denser medium. Actually, if it is a single medium means light rays will not bend. It will move in a straight line in a same medium means. But it is going to move from outer medium to the core. That is moves from rarer medium to denser medium. That's why light ray, refracted ray bend towards the normal. Bend towards the normal. When light moves from rarer medium to denser medium, light ray bend towards the normal. Refracted ray bend towards the normal. So that's why if it is actual path, it will not move in that straight line path, bend towards the normal. Like that. So there we have here two angles. Normal, interfacing normal, this axis acts as a normal to the incident ray, angle of incidence. Here we are mentioning IA. IA is angle of incidence for the acceptance angle. Angle of incidence for the acceptance angle. Then here we are going to take an angle of refraction at the acceptance space, that is RA. When light moves from, that is signal moves from outside that fiber to that core, there we have a angle of incidence IA, angle of refraction called as a RA. After that, if it is a moves in that core at one stage, it want to move from core to the gladding. The interface point we are going to draw the normal. Suppose this refracted ray in that core going to graces the separation of the two medium. Which two medium means core and gladding. So that's why here this angle, if it is along the separation of the two medium, it is moves at this instant. Their angle of refraction may taken as a 90 degree. Their angle of refraction is a 90 degree. This angle is called critical angle IC. Critical angle IC. At this point we are going to mention the A. That is outer to the core interface point A. Core to the gladding interface point may be taken as a B. And at this point we are going to mention as a C. Here we are going to apply a Snell's law in a product form. At the interface of outer to the core one time, then core to that gladding interface we are going to apply a Snell's law product form. First we are going to apply it at a point A. At interface of outer to core, we are going to apply a Snell's law in a product form. That is A point applying Snell's law in product form. Snell's law in a product form. At this point, if you apply a Snell's law in product form, means refractive index of this outer medium into sine of this angle of incidence equal to refractive index of that core medium into sine of angle of refraction. First we are going to take an n3 equal to, that is n3 into sine Ia equal to, that is n3 into sine of angle, that is Ia equal to, that is a core refractive index n1 sine Ra is the first equation. So at the interface A point we are applying a Snell's law in a product form. Similarly we are going to apply the Snell's law in product form at the interface of core to the cladding. Snell's law, that is first we have applied this equation 1 outer to the core. Next we are going to apply core to the cladding interface. At that point B, we are going to apply the Snell's law in product form. There core refractive index is n1, that sine of angle, which angle we are going to use means IC. That's why n1 sine IC equal to, this is the second medium, there refractive index is n2. Then n2 sine, what angle we have, that is 90 degree. This is the second equation. In our second equation, the angle of refraction is 90 degree. That's why sine 90, this value becomes a 1. Then this equation is going to rearrange it as n1 sine IC, critical angle. IC is nothing but critical angle. n1 sine IC equal to n2 alone, because sine 90 becomes a 1. So from this equation 3, we are going to rearrange the sine IC alone. That is sine IC equal to, what is that means? n2 divided by n1, equation 4. Sine IC is equal to n2 divided by n1. In our diagram, this is a right angle triangle. We are going to take an ABC. Their total angle is 180 degree. One of that angle is 90 degree plus another two angles are RA plus IC. So from this we simplify that. This 90 is taken, left side we will get, that is 180 minus 90 becomes a 90 equal to RA plus IC. From this we are going to get critical angle IC is equal to 90 minus RA at the interface of that first angle of refraction RA. So from our right angle triangle ABC we get this condition. Finally we will get, that is IC is equal to 90 minus RA. This may be taken as equation 5. Instead of IC, now I am going to substitute 90 minus R in that equation 4. In equation 4, instead of IC, I am going to substitute 90 minus RA. So we will get that equation sine of 90 minus RA equal to n2 divided by n1. What is that? Sine 90 minus theta, that is cos theta. That's why cos RA is equal to n2 divided by n1. Can be taken as equation 6. But what I want to means, in our first equation, we want to substitute the value of sin RA. But from our that sin IC, we got that cos RA. In that sin IC, we got that cos RA. Now I need that sin RA. Based on that mathematical form, sin RA is equal to square root of 1 minus cos squared RA. Here, instead of that cos RA, we are going to substitute that refractive index of that second medium divided by that refractive index of that first medium. So, sin RA equal to square root of 1 minus n2 square divided by n1 square. We rearrange that sin RA equal to square root of n1 square minus n2 square divided by n1 square. Is the sin RA value may be taken as the equation 7. This equation is going to substitute in our equation 1. What is that equation 1 means? We know that equation 1 is n3 sin IA equal to n1 sin RA. Now we are going to substitute that sin RA value from the equation 7. From the equation 7. If we substitute it, n3 into sin IA equal to n1 into what value we are going to take? Square root of n1 square minus n2 square divided by n1 square. That is into square root of n1 square minus n2 square divided by n1 square. Then if you take on this n1 inner of the square root, n1 becomes n1 square. The denominator and the numerator both are having that same n1 square divided by n1 square. That is going to cancel. Then is n3 sin IA equal to square root of n1 square minus n2 square. n3 into sin IA, that is acceptance angle, equal to square root of n1 square minus n2 square. Next we are going to get that acceptance angle. What angle that light signal want to enter from outer to that core, that is called as a acceptance angle. That we need. From this equation we are going to take. So that n3 sin IA equal to square root of n1 square minus n2 square is going to rearrange it as sin IA equal to square root of n1 square minus n2 square, in the square root itself n3 square we can take. In general, light source where we are placing? In air medium. If it is that is a outer medium is air medium. If outer medium is air, n3 is equal to 1. Then what about that value for that n3 square? That also becomes a 1. That's why sin IA equal to square root of n1 square minus n2 square. We need only IA alone. That's why take sin inverse on both sides. Take sin inverse on both sides. In left side, sin and sin inverse are going to cancel. So that's why we will get IA is equal to sin inverse of square root of n1 square minus n2 square. This is called as a acceptance angle. This is called as a acceptance angles. What is the formula for that acceptance angles means? IA is equal to sin inverse of square root of n1 square minus n2 square. If it is the outer medium is air medium. If it is any liquid medium means there we have a refractive index greater than the 1. That's why IA is depends upon that is acceptance angle depends upon. Refractive index is of core, gladding and outer medium. In general, the outer medium may be taken as air. Suppose in case this cable is going to immerse in a water or in any other oil medium, then we need the value of refractive index N3. If it is a standard air medium means no problem, N3 is equal to 1 itself, we can substitute. If the cable is placed in air medium means, then the N3 value automatically, no need to given to solve the problems. So N3 value becomes a 1 itself. And these acceptance angles, what angle we have? Up to that angle only, light should be enters from outer medium to that core medium. So for that, we are going to draw a diagram to represent that conical portion to enters inside that. Only in that conical portion alone, light can be enters to make a total internal reflection. Then what conical shape of that light is want to enter, that is called as a acceptance cone. Now we are going to draw a diagram for acceptance cone. How we can draw, we will see. Now we are going to see that drawing the diagram of acceptance cone. So we know that already from a zero angle to acceptance angle only, if light is entered from outside to that core, then only it will make a total internal reflection. And it can be transmitted to the receiver. Above that IA, if the light is incident, the core to the gladding interface, angle of incidence is less than the critical angle. If angle of incidence is less than the critical angle, it will not make a total internal reflection, it makes a refraction. So that is very important that our fiber cable we are going to tackle. This is fiber cable fully. But we have the two mediums. The core medium and the gladding medium. There we have an axis also. Axis of the fiber. For this axis, interfacing light from outside to the core should be makes a certain angle. That angle is acceptance angle. So the incident ray may be taken like that. From the axis to this line only, that acceptance angle is going to taken. Not only that two-dimensional manner we are going to taken. If it is three-dimensional, if it taken, any direction, if you send that light from outside to that core, it should be making angle from 0 to IA alone. For all points, maximum angle IA, drawing the line, all lines joined to form a conical shape. So that cone is called as a acceptance cone. It can be transmitted like that. So from 0 degree to IA, if light enters from outside to that core, then only it will make a total reflection and can be transmitted through the core only. If that angles making all direction, that makes a conical shape, that is called as a acceptance cone. that is called as a acceptance cone. And we have the equation n3, that is n3 into sin Ia. That value can be taken as square root of n1 square minus n2 square. May call as a numerical aperture. It is called as numerical aperture, shortly named as Na alone. If it is the outer medium is air medium, but we can take an Na only sin Ia. If it is general, Na is equal to n3 sin Ia equal to square root of n1 square minus n2 square. Outer medium is air, n3 is equal to 1, Na equal to numerical aperture is equal to sin Ia is equal to square root of n1 square minus n2 square. Whatever may be that, acceptance angles depends upon the refractive index of the core, refractive index of the cladding, and refractive index of the outer medium. Okay, that's all about that optical fiber. Once again, we can recall that optical fiber is a device used to transmit informations from one end to the another end as a light signals. What principle is used? Total internal reflection. That optical fibers are very thin fibers which are in a cylindrical shape and made up of either glass or plastic. Either glass or plastic. Due to that principle used in that optical fiber total internal reflection, whatever may be, you make either twisting or bending the cable, that the light will not comes out from that core, can be transmitted from transmission end to that receiving end almost without loss the intensity of that light enter. The maximum intensity can be received at that receiving end, and it is the most important communication media in nowadays. It replaces that electrical cables in many places. Not only that, for network also we are using optical fiber cables because of more advantage as compared to that electrical cables. Now we are going to see. Okay, listen. Our example problem 6.10, that is related to that optical fiber. The optical fiber is made up of a core, has refractive index 1.61. Based on our expression, it will taken that is n1. And cladding has refractive index 1.44. This can be taken as n2. And what they are saying means, what is the acceptance angle of the fiber when it is kept in that air medium. So that's why if it is kept in air medium, that outer medium is air medium, then its refractive index n3 equal to 1. So now we are going to see the acceptance angle for this relation group. Then separately we will calculate that what is the answer if there is no cladding. If there is no cladding means air is going to consider as a cladding. So that may be that. For first condition we are going to calculate. Then that is a given data. What are the given data we have means n1 value, that is 1.68. Then n2 value 1.44. n3 value, because outer medium is air medium, n3 is equal to 1. Then we want to find acceptance angle. To find acceptance angle. IA. We have a formula. We know that expression n3 into sin IA equal to square root of n1 square minus n2 square. There n3 value is equal to 1. Then we want to find IA. That's why in the solution we are going to tackle IA is equal to sin inverse of square root of n1 square minus n2 square. Now we are going to substitute IA is equal to sin inverse of square root of 1.68 whole square minus 1.44 whole square. If you square out both sides, that is a square of that 1.68 and a square of 1.44, finally we will get IA is equal to sin inverse of 0.865 value, almost equal to that 0.866. Which value gives 0.866 means we know that is root 3 by 2 equal to 1.732 divided by 2. Its value almost equal to 0.866. Sin of which value, which angle gives that root 3 by 2 means that is a 60 degree. That's why here IA is almost equal to 60 degree. Acceptant angle for that relation. Refractive index of the core is 1.68, refractive index of the cladding is 1.44, as well as the outer medium is air medium, their acceptance angle that is 60. It is a maximum angle. It is a maximum angle to make a transmitting signal from that transmitted end to that receiving end. If that is core refractive index and the cladding refractive index are this alone. Suppose we have core only, no cladding. For that condition, what we can take n2 is equal to 1. If there is no cladding, then n2 is equal to 1. n1 is equal to 1.68. 1.68. Then we are going to calculate that acceptance angle. IA is equal to sin inverse of, that is sin inverse of square root of 1.68 whole square minus 1. That is 1 square. That is we will get that. Here sin IA is equal to, that is sin IA is equal to sin inverse of square root of that 1.68 square minus 1 can be gives that value totally it will becomes 1.35. That IA is equal to sin inverse of 1.35. It is impossible condition. The sin maximum value is 1 alone. That is, if you substitute 0 to 90 degree, at that 90 degree we have that sin value maximum is 1. So it is impossible to transmit a signal from one end to another end. So what we need, that we want to see, this value should be square root of n1 square minus n2 square should be less than or equal to 1, then only there we will get that sin inverse value. So for getting acceptance condition, that is sin inverse of square root of n1 square minus n2 square should be value is less than or is equal to 90 degree. If we need a sin inverse of square root of n1 square minus n2 square is less than or is equal to 90, then that n1 square minus n2 square should be less than or is equal to root 1. Then it will taken rearranged and finally we will get n1 should be less than or is equal to root 2, because this n1 n2 becomes a 1, n squared becomes a 1 itself. That's why we get that n1 is less than or is equal to 2. That is n1 value less than or is equal to 1.414. At this, and that is the value, if the core has this value, that is 1.414 or less than 1.141 refractive index for the core, means we no need that gladding. The gladding, air can be act as a gladding. So that is the necessity condition. For without gladding, we can transmit the signal through the core we required, means that core should has that refractive index 1.414 or less than 1.41. That is the answer of our second question. That is, what is the answer if there is no gladding? Means if there is no gladding, the core should has refractive index maximum value is 1.414 or less than 1.414. Then only that signal can be transmitted from transmission end to the receiving end. Okay, thank you for